Alright, so what we're going to do in this video is we're going to talk about the solar nebula theory, which has gone by a few different names over the course of the years that scientists have been researching how we, basically our solar system, and all the planets and everything else that's located within our solar system has been formed. So we're going to talk about the details regarding this theory as to how basically our solar system was created. So the learning target hits E5.3-3, explaining how the solar system was formed from dust and gas within the spiral arm of the Milky Way galaxy, give or take 4.6 billion years ago, as that goes. So here's what the theory says in the simplest of terms. It explains how planetary systems in our solar system, so talking about how planets like Mars, Jupiter, Earth, Uranus, Neptune, so on and so forth, were created, as well as other systems within our universe. So in other galaxies, planet-like systems that we have been able to see using technology such as Hubble. And how they were all formed from just simple dust and gas to form what we now see as these sometimes very small like objects such as asteroids, or as big as planets like Jupiter, and as big as our sun, if not even bigger than those items. So there are a couple things that we need to first spend some time talking about. Okay, and there are some terms that are going to be brand new to most of us because, well, you've never studied the nebular theory before. So what I'm going to start off with is what a supernova is. A supernova is literally created when a star dies. Okay, that's what a supernova is. The star suddenly basically increases in brightness, and the brightness literally is even brighter than our actual sun because of this explosion. And as it explodes, it ejects all of its mass that once made up this massive star, and it shoots it out into space, and it becomes something that's quite bright. And to be honest, we actually had one that scientists came across in September, and you could actually see it. If you looked up in the sky, you saw kind of a glimmering whitish light that kind of looked like a sparkling star, a twinkling star. But if you looked at it with binoculars, you could actually see the colors, and the colors were quite amazing. You could see some reds and greens and some neon type colors, and it was actually very cool to actually see. Nebula. Nebula is the second term that we're going to focus on, and what it is a cloud of gas and dust in space. So this is what basically started the planets to be, well, created, so that we have them now as we see them. So it was just basically a cloud of dust and gas out in our space. A protostar. A protostar is a star that is still forming, and nuclear fusion has not yet begun. Now, nuclear fusion, as you've already seen potentially, depending on the order in which you're working in, nuclear fusion is what takes place on our sun that takes lighter elements to create heavier elements, such as helium turning itself into hydrogen turning itself into helium, and vice versa, and those things merging to then make up the other elements that we have within our solar system and even in our own universe. So what happens is gas and dust are beginning to literally group themselves together. They're collapsing because gravity's pulling everything into the center, and as it does this, it starts to clump itself, and as it spins around and around and around real fast, it starts to mold itself into what we now see as a star, something that's more solid and packed in the middle. A protosun is very similar to what a protostar is. It's a star that is still being formed. So it hasn't yet completely formed into what it eventually will become. It's the birthing stages. It's developing. It's growing. So this would be the very early stages of an actual solar system that's being developed. And as we use Hubble and we look out, we can see some pretty amazing pictures of how solar systems are being formed in other galaxies. So what happens is a protosun is the central material. It's at the heart of an actual galaxy, or at the heart of the beginning stages of the creation of a solar system. And eventually what will happen to a protosun is it will become the sun, very much like ours is to our solar system when nuclear fusion begins, where we start to merge together and start to create these heavier elements. A protoplanet is, again, where you start off with gas, and you start off with dust, and even take some of the materials such as debris that's already out there. And because of gravity, and as it collapses and pulls itself together, it starts to pack itself in, and then eventually will lead itself to becoming an actual planet, very much like Earth, Mercury, Mars, for example. So, talking about exactly what took place in order for us to form our actual solar system. The first thing is that scientists, as they've researched this, know that we started as a dust of debris and gases all out in our universe at some point. And then there had to be something that disturbed it. Scientists believe that it was an actual explosion of a supernova. So what happened was you had this cloud of dust and debris that was sitting out here. And what then took place is you had this star. This star, as it was taking and basically pulling itself in, and then eventually collapses and then explodes. And what it does is it then sends this dust and debris and all this other energy out into space. And as it's headed out into space, what it then eventually would do is it would run into the cloud of dust and gas, and it would actually start to transform it by giving it a source of energy. And that source of energy would then take those dust and gas and start them to actually mold themselves and kind of spin until they start to clump together by the forces of gravity. Step 2, we'll get to in a moment. Let me start off by showing you some examples of what a supernova looks like.
That's what I'm talking about. I'll make it funky one time. If you are what you say you are, a superstar, then have no fear. The camera's here, and the microphones, and they wanna know. Oh, 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 yeah. If you are what you say you are, a superstar, then have no fear. The crowd is here, and the lights are on, and they wanna show. Oh, 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 yeah.
So, kind of a cool little video I took when I was outside. It was September 9th, as I looked at the date in which but nonetheless pretty cool. What I then did is I plugged it into the software I used to do the recording for all these videos, and then blew it up. So it might have been a little blurry, but nonetheless you could see how it moves around and changes based on the gases that are interacting with one another. So how does that actually come to fruition? How does this all come together? Well, when you have the supernova that literally explodes and sends all of this mass out, including the energy, what it does is the great cloud of gas and dust, the nebula that's floating out there, begins to collapse because that energy causes it to start to interact and start to move around, and the pressure that comes with it, it creates this collapsing where it brings everything else into it. And when that happens, this process of spinning, it starts off nice and slow, but it's just like when you start off rolling a ball down a hill. It starts off slow and then eventually gets faster and faster and faster. And the reason why it does that is because of something that's called angular momentum. Now, you probably have never heard of angular momentum, don't really understand it, and that's perfectly fine. But I have something that I can show you that will basically explain exactly what happens with angular momentum when we talk about the spinning of, well, the creation of our actual solar system. The perfect example I have for you is an ice skater. Okay, what I would like you to do is I want you to watch exactly what happens to the ice skater when the material, her body, is separated. So what's called an open spin. You notice she spins around, and to you and I that appears to be going quite fast. So in an open spin where all the material is still floating out there in space, it appears to be going fast, but it's really not. When you start to bring all of the material into the middle, like you see with her bringing her hands in, she starts to spin faster and faster and faster. So the angular momentum is when you take all the material that is spaced out in space and you start to pull it together, it then gains more momentum and starts to spin faster and faster and faster. And the faster it spins, the more material it can pull in and kind of clump itself together to eventually then make, well, as we know, our actual solar system. So the final step as we move towards the end of our solar system creation is when we start to spin around and around, as you can see in this diagram, we start to move faster and faster and faster. What happens is we start to flatten ourselves out like a pancake. For those of you that have ever seen pizza dough being flipped around, it starts as a bulge, and as you spin it around, you punch it with your hand, it starts to smooth itself out. Well, what was also happening is there was a bulge at the very center of all of this fast-moving material around it. That bulge eventually ended up being what we now know as our actual sun. And then from that point, all that dust that was floating out into space began to clump itself together as well and began to form what we talked about, protoplanets. And then we had our proto-sun, which was the beginning stages of the actual sun being created. And then all the other materials out there as well, such as moons, asteroids, and any other dust and debris that is found within our actual solar system. So we can still see the remnants, the leftover material that is out there from when this whole process started, long time ago. And those materials are literally the asteroids and the things that we find in our what's called the Kuiper Belt or the Oort cloud. Small dust, small particles that literally did not clump together because they were still not all together pulled in. So they may have been a part of a larger mass at some point and then broke apart. But nonetheless, we still see the kind of leftover material that wasn't clumped together by gravitational forces that started our very beginning of our solar system many, many years ago. So, again, when all of these things are happening, this is where we come up with the proto-sun, the proto-star, and also the proto-planets, is when all of this dust and material starts to clump itself together as it starts to revolve around what we then called our proto-sun or proto-star, which now we know as our